I'm Filip Popovic. I'm program manager in Serverless SQL pool team, actually Synapse SQL team, and my primary focus area is performance. So obviously, topic that I would really like us to have discussion rather than me delivering a session. So feel free to ask questions, either just pick up or send a question in a chat, and Marcus or someone will read it out because I don't see the chat. I see that you started meeting in person. It's really nice to see that after almost two and a half, let's say, years. I hope next time I will have opportunity to meet you in person. But until then, let's move on. So today's primary topic is performance. Yet I would like to first hear or learn how many of you have used Serverless SQL pool so far. It will help me to understand how much should I give of introduction. So I guess we can raise a hand in Teams or. Okay, so numbers going up. That's nice to see. I see you, Marcus, as well. Okay, so we have a few folks that didn't use Serverless SQL pool, so we will spend the first half or a bit less of this session talking about what the Serverless SQL pool actually is. As you know, the Azure Synapse Analytics is the complete end-to-end analytics solution. And within the Synapse Analytics, there are multiple compute engines, Spark and SQL pools. And I will focus on SQL pools for the beginning. We have this dedicated and serverless SQL pool, and even the service is in GA for 2 or so years, and we still see customers from time to time not being aware that some things and what things can be done in serverless SQL pool. So let's explain the difference first. That's the first part of the meeting. Then we will go to the recommended scenarios and patterns, like what we saw our customers doing and what you can do with the serverless. We'll speak a bit under the hood, how the queries are executed and how this scale out and fault tolerance are achieved. And finally, we will move to performance best practices. You see a Q&A in agenda, but yeah, as we said, just feel free to interrupt me whenever you have a question. We have plenty of time. I expect that I need somewhere around 1 hour, a bit less than 1 hour, to go through all these topics. So we have plenty of time for your questions. So feel free to interrupt me. So what is serverless Synapse SQL pool? Basically, it's a T-SQL. It's the engine that enables you to use T-SQL to query data over the data lake, Cosmos DB, and Dataverse. But let's see in a practice what does that actually mean. So I'll just skip to SSMS and show a few simple queries over files. Okay. So
Filip, just a quick question: are you sharing already? Because if so, we don't.
I was thinking that I did, but I didn't. Sorry for that.
Now you're actually doing it.
Now it looks much better, right?
The best possible window, SSMS. Welcome to the group.
So I'll just quickly deviate from SSMS and go to Synapse Studio. This is the web UI for Synapse Analytics. You can use it to manage your environment, to monitor it, to write scripts, run scripts, explore your storage, explore your databases like in Object Explorer. So I will just use it now to browse through my storage. And basically, I will show you that there are some files in a storage account, in some folder, demo2 in this case, and some files of different formats. So how Serverless SQL pool can help you. So basically, if you use right-click and select top star in a Synapse Studio, it will behind it will generate a Serverless SQL pool script that will read this particular file from storage. So it's as simple as that. You can get an easier to query files using SQL. So what we will see here is quickly, hopefully, is the content of this file. So here we have the content of this file without knowing anything about that file. So usually if you want to do with anything with files, especially with SQL, you need to open Notepad or some other tool, analyze the content, see schema, validate it's fine, and then import it to SQL, probably fail at least a few times because of invalid values, data types, and so on. But with Serverless SQL pool, it should be as easy as this. So basically, you can see the content of your file, you can inspect it, you can understand the values. Now you can search for distinct values, maybe do some group by aggregations, whatever you want. You can write any T-SQL, basically just like over any table, but this time it's on the top of files from storage. So basically the idea of this part is just to show how easy it is and to show you one more thing. I will not go into a lot of syntax, but I just want to show you some argument that will let you actually to force serverless SQL pool to read column names from the file. So if you see the query that I executed have columns C1, C2, C3. With this header row equals true, the engine will actually understand what are the columns. This query returned the error. Basically, I didn't see the rows for one simple reason. I lack column names for the last two columns. But anyway, I got invalid files, but I quickly can understand it and see what's in there. So this error is on purpose. Anyway, if the file is valid, you would see it's just like any table with the proper column names and proper data types. Also, data types are inferred based on a sample. So the engine read the first 8 megs of file, 8 megs, I believe, and deduced types for each column. So basically it checks whether it's all numbers. Great, it's big int. If it's characters, it's varchar, right? And finally, if it's some date, it will use a date type. So now, when we understood what it actually is and how you can use it, at least for a start, let's continue with the presentation. So the benefits of serverless SQL pool is that you can use T-SQL, meaning that the engine that you're familiar with, but not only you, not only humans, also the tools, different tools understand T-SQL, either coming from Microsoft, like Power BI, or maybe some custom tools that fire different queries to list tables, metadata from your endpoint, like Azure Data Studio SSMS, or even Tableau. So basically, you can run most likely any tool that is capable to establish TDS connection, meaning to connect to SQL Server. It will be able to connect here as well. It means also not only tools, but libraries. So any JDBC, ODBC, ADO.NET code you have will be able to access the serverless SQL pool. There is, since it's an integral part of Synapse Analytics, and as you know, there are different compute engines, meaning Spark in this case, it's meant to solve the ages-old issue of collaboration between Spark teams and SQL teams. So imagine if you have some data science team, they are probably using Spark or Databricks. They can create some tables in Spark, do any machine learning magic they know and need to do, but no one can use those data, right? Because somehow you need to get those files into SQL to understand them. With a serverless SQL pool, it's not the case anymore. Basically, you can start querying the tables as soon as someone created them in Spark, and that makes the collaboration between Spark teams and SQL teams, business analysts, quite easy. Then it's not about storage, right? Because you have data in other systems. Currently, Cosmos DB is supported. So if you have data in your Cosmos DB, you can configure it with just a few clicks. So serverless SQL pool can access that data from Cosmos DB. And you probably already know if you use Cosmos DB, it's great for throughput, for transactions, it's fantastic. But once you move to analytics workload, you try to do some analytic queries on Cosmos DB, it's slow and it's quite expensive. So with this link, you get cheap analytics on top of Cosmos DB in near real time. Another thing that's not mentioned here is Dataverse, meaning that some dynamics data can be exported to your storage and queried the same way from serverless. Interesting thing that you don't need to build ETLs for this. You just need configuration, like few clicks, and from there on, you just use serverless SQL pool and query that data, just like it's in any other SQL that you used to. You hear me keep repeating the serverless.
Sorry.
One quick question.
Quick question here.
Regarding the connection between the serverless SQL pool and the Cosmos DB. So I am aware that there is a Synapse link for Cosmos DB that is existing, but like, is this basically like the same technology that you are talking about, or is like the connection from serverless SQL to Cosmos another thing?
That's a good question. I will cover it in more details later. I have a slide for that. Basically, what happens is that you enable analytical storage. So Cosmos DB, there is ETL in behind that continuously exhausts data from Cosmos DB to analytical storage, and Serverless SQL Pool then queries that analytical storage. So basically, you offload your Cosmos DB storage. You don't spend RUs there, resource units. So basically, when you're querying this analytical storage, there is a cost for storage, which is low, as you know already. But the engine, the compute engine, is this one that we discussed today, Serverless SQL Pool.
Okay, let's see. Like, okay, I'm going to be interested. But okay, like I understood, like he's going to query the analytics store of the Cosmos DB. Okay, cool.
Okay. Well, back to serverless as a word, it means that it automatically scales and manages itself. Basically, you provision Synapse Analytics workspace, and among this Synapse Web UI Studio that I show, you also get Serverless SQL Pool endpoint. And you pay only for queries that you run, and the charging is based on data processed. So basically, you can spin up your workspace, provision your workspace, not use it for 3 months, come back. So the cost is zero. You run a query, then you get charged for data processed. It's scalable, meaning that depending on the query complexity and the amount of data that your query will process, it scales automatically. So you don't care about the number of nodes, size of nodes, RAMs, CPUs, anything. Basically, you just connect and run a query. It's pay-per-use model, as we explained, and it's fast for querying this storage data. And there is an automatic schema inference, as I showed in a demo. Basically, it can deduce the schema for you. So it's really easy to start with. You just don't care what's in the file. You can select star and then see what's there with your favorite tool, SSMS, ADS, whatever it is, and then start running it. During the preview, we saw customers were like kind of reluctant to rewrite their code to rely on serverless instead of the SQL database, which is fine. It was in a preview, right? But then they were quite happy with the fact that basically they daily or monthly get new files from different data providers. They get new projects often, meaning new data sources. And they often struggle with this phase of understanding what's there, dealing with dirty data and such things. With Serverless SQL Pool, they basically put zero effort in all that I mentioned. They started querying the files, understanding what's there, finding errors, correcting their SQLs. And during that process, basically, they realized that they end up with a SQL as it should be to ingest the data further into Power BI or AAS. So some of them decided to discard SQL DB or SQL Data Warehouse in between, so they don't ingest the data. They directly feed PBI and AAS through this Serverless SQL Pool, and that they were quite happy with that. With this being said, I'm not trying to say that this is replacement for SQL DB. For sure, it's not. I'm just saying that for some customers, it was game changer. For others, it was an addition. Valuable addition to analytics, but for some it was even a replacement for some other technology they used.
Philip, sorry, the quality of your audio is not very good. Probably because of the internet connection. So we have trouble hearing you. You might consider switching off your camera, although we also love to see you, but do switch off your camera so you have more bandwidth for.
I did. Is it better now? I believe not.
Thanks so much.
Is it better?
Yeah.
Yeah. Oh, strange. Thanks. Okay. So moving on. So in Synapse Analytics, you have two kinds of SQL pools: Serverless SQL Pool, which is our topic today, and dedicated SQL pools, which is improved and greatly enhanced SQL Data Warehouse as you know it from before. And this brought a lot of confusion. So I would like to spend a few minutes on this and next slide to explain the differences. With a dedicated SQL pool, you need to ingest the data. It's a traditional relational database engine, a distributed one actually, where you ingest the data from the lake or any other system into the database. And then it's in highly optimized managed storage. You can create indexes, materialized views, use results at caching, whatever there is, and get the great sub-second performance. But on the other hand, on the right-hand side, serverless SQL pool is not, you cannot ingest data into a SQL pool. You can only use it to query data from your storage, meaning that there is no ingestion phase. You read data directly from the storage, meaning near real time. As soon as you upload the data to the storage, it's available for querying, no additional step needed. Of course, it comes at the expense of service being forced to read data from storage and parse it in case of CSV or decompress it in case of Parquet. But basically, you remove the ingestion step, and for many cases, this is performant enough. So the different angle, different perspective to this dedicated versus serverless, because we often get questions, when should I use one or the other? So let's speak about concept. There is a real-time reporting, which basically you get the latest version of data, no ETL, and there is interactive, which provides sub-second response for, let's say, direct query scenario for Power BI or AAS. So real-time and at the cross of real-time and interactive analytics, you have dedicated pools because it's highly optimized for interactive queries, subsequent response, massive concurrency, and it's expected because it has column store, materialized use, result set caching, all the technologies, all the features needed for sub-second responses. If you want a real-time and non-interactive analytics, then serverless SQL pool is solution, either over data lake or Cosmos DB. And this is just purely for the reason that I mentioned. We need to read data from storage, parse it, so obviously it cannot be expected to like return result set within in a sub-second way. So for the non-real-time and interactive analytics, again, you would need a dedicated SQL pool because you will have ETL, which will fill the dedicated pools with data, and then you will utilize all the features to achieve the sub-second response. That being said, serverless SQL pool is great, actually, a great fit for Power BI scenarios, import mode. For a direct query, it really depends on your scenario. I would say, in general case, if I would have to provide a binary answer, I would say for interactive analytics, definitely dedicated pool is the way to go. For import mode for Power BI or AAS, serverless is a great and cheap way to do it in a performant way. So where is the place in your architecture for SQL pools? It's right in the middle between external storage and your reporting layer. So this is the same story, just from a different angle. With the serverless SQL pool, you get a different benefits, right? You can start immediately. It's as easy as writing a simple select statement. You get the near real-time reporting. It's optimized access, meaning that it's heavily optimized to work with storage and with CSV and Parquet files. And there is no ETL delay, right? Because there is no ingestion phase. You just open up your SSMS and write a query, that's it. And since it's T-SQL, it's quite easy to feed the data to the reporting layer, whichever one it is. Again, a similar perspective, but this time from different roles. We all know that depending on who you speak to and what's the goal for that person would like to utilize particular technology, or maybe has a limited skill set, so knows only Spark or knows only SQL. So the idea is to let everyone do what they know best. Data engineers will refine data with various tools. In this case, it would be Spark pools or Databricks. Anyway, data will reside in a storage, and then the SQL users can just point to that particular location in a storage and read files. You see here Delta. So basically, I mentioned CSV and Parquet, but Delta is supported as well as JSON, and Cosmos DB is supported as a source as well, right? So with this flow, you have different people working on the very same set of data, no duplication of that data on different places, and feed the Power BI report for whomever is needed. Another interesting scenario that we saw is once we separated compute, meaning serverless SQL pool from storage, basically we achieved ability to have different engines or different serverless SQL pools access the very same data. In case you need isolation for any reason, maybe you want to separate charges for some teams or departments, maybe you want to share some data on your storage to provide access to your storage subset of data in your storage to some department in another country or maybe even another company, whatever there is. But basically, once we separated these, you had much more options to scale your workload and share data as well. And this is a slide where I would like us to go into a bit more details of Cosmos DB. So basically the question that we heard at the beginning of this presentation. So Cosmos DB is quite good, high throughput transactional system. It's great, it's awesome for that, but once you try to run analytical queries on top of that, it falls short. It's either slow or too expensive for most of the cases. That's because Cosmos DB storage is transactional store. It's row store optimized. It's optimized for transactional operations, like quick lookups, working just with a handful of rows. For analytical workloads, we need more than that, right? We know from a long time ago that transactional stores just can't keep up with the analytical needs. So with a few checkboxes, you can enable analytical store on Cosmos DB. What happens in behind is that actually there is a storage that data is exhausted to. You don't have direct access to this storage, but basically that is analytical store. So you pay for some storage content. You can find pricing at the Cosmos DB pricing page. But the key point is that you don't care about it. It's just a matter of checkbox. As soon as you check it, enable it, automatically data from transactional store will be exhausted to analytical store. And as you keep adding and changing data in the transactional store, those changes will be applied to analytical store automatically. So basically zero ETL from your side, zero maintenance, zero effort, zero development. It's just a matter of enabling this feature. And the ETL is automatically working under the hood. This exists for Cosmos DB, but it exists for Dataverse as well. And once it happens, Azure Synapse Link is actually the name of the feature that allows serverless SQL pool to work with this analytical store. From your perspective, from the end user perspective, it is yet another table in yet another set of files within a storage. So basically, with the very same statement, like open row set or external table, you can access this data and provide it to any tool that you want to use. We saw many use cases. There were machine learning use cases where basically the engines were using serverless SQL pool to query data directly from the storage. For example, Azure ML, you can use it to query through the data in storage to serverless SQL pool. You can do big data analytics. You can create dashboards with the Power BI or reports quite easily. So are there any questions so far? I guess not. Okay, so
there's no. Yeah.
Thanks. Yeah. This is quick introduction on what the serverless SQL pool actually is and what you can do with it. So let's quickly go through what's under the hood or what happens when you submit a query and how it handles auto scaling and fault tolerance. So distributed query execution flow. Well, it's good to understand this because that way you will understand how your queries are executed in this environment and what you can do in some phases to help it run faster. So when you connect to endpoint using SSMS or whatever tool, you're basically connecting to what we call SQL frontend, and that's customized SQL Server. So for those who used SQL Data Warehouse, in SQL Data Warehouse it was a C# application, and that's why you had this D-SQL instead of T-SQL in a data warehouse. And that's why it was not completely the same syntax as in the T-SQL. Now, this time we decided to go with a native process there and use SQL frontend, meaning customized SQL for the purpose of serverless SQL pool. So when you connect to it, it's literally for tools, it's just like you're connecting to any SQL server. It's just a matter of the scope of T-SQL that is covered. Basically, you cannot ingest data, so there is no insert into or things like that. But arbitrary selects work, and also you can use create database to handle your metadata or to organize your workloads into schemas. You can create roles, users, logins, configure security, and things like that. We often get questions, well, it's serverless, but what happens with our metadata? Your metadata is safe and it's not serverless. So it's not stateless in terms of metadata. Your metadata is always there. It's just that there is no data in serverless SQL pool. So serverless SQL pool runs your query by reading from storage, processing in memory, and returning result set. No data is stored within the engine itself, while metadata is always there. So you can create database, come back in a year, your database will be there. You will not lose it. When you submit a query, SQL frontend does pretty similar job that any SQL server does. So there is a query simplification where we do a filter push down, then we list files from storage, check if you want to perform some partition elimination. So we eliminate some files to reduce I/O. And basically, when we parse and compile and bind metadata for this query, SQL frontend passes it to DQP, which is a new component. So it's not customized, it's a new one. This one explores viable distributed execution plans based on the input from SQL frontend and picks the one with the lowest estimated cost. So pretty much like SQLs, other SQLs. The key activity here is breaking down user submitted query into T-SQL fragments. So those T-SQL fragments are to be scheduled for execution on backend nodes. And backend nodes are the ones that are truly stateless. Truly stateless means that while you are using those backend nodes, they keep nothing but the metadata for currently executing query. And if you come back tomorrow, you will probably get another set of backends because in the meantime, we will release the backends you used yesterday and we give it to some other customer. And you can stay assured that it's all a secure environment. All these backends and any node in a serverless SQL pool is written out with zeros. So basically, it's emptied after it is taken away from you. So no other customer or malicious user or some hack, if anyone manages to hack it, will be able to access your data. Basically, you can rest assured that your data is safe and they are truly stateless. Speaking of tasks, I would like to provide an example just for an easier understanding. Let's say that we have a select with a join of two tables. Lower level nodes, leaf level nodes, will read from storage and maybe apply some where filter if there is where filter. And then the nodes above will do the joins of the tables received from the SQL backends. Once they do the joins, they will stream the result set back to the upper levels of the query graph until finally it lands on a SQL frontend and it is returned to the client tool. So there is another crucial difference between this engine and other SQL engines. Any SQL engine other than serverless SQL pool today works in a way that engine returns the first batch of rows as soon as it gets one, right? In serverless SQL pool, because we have this last step of data landing to SQL frontend, it means that first the engine gets the whole result set and only then starts streaming to the client. So I had to explain this because we often get questions, hey, in a SQL DB, I start getting result set much faster than here. Well, yes. Yeah.
One question. Does that mean that there's no caching happening anywhere because we're stateless, right?
Yeah, today that's the case.
Okay.
So we sometimes get questions like why SQL DB returns data faster? Well, we need to make distinction between starts returning data faster, meaning returns first row soon faster than the serverless SQL pool. We need to make distinction between that and the actual query duration. You probably don't care about the first result, or you care less about it. Then you actually care on how much the whole query duration will be. So this is one of crucial differences between this and the other engines today. Serverless SQL pool is built on the engine called Polaris. There is a paper on VLDB that you can find, or I can share the link if you're interested. So it inherited some key characteristics like being distributed system as described so far and being able to query any data. So we have some files on a data lake and DQP and the whole engine serverless needs to be, should not care what format is the data, right? Any format like CSV, JSON, Parquet, your engine should be able to process it. This is achieved by abstracting files with data cells. So basically the engine is dealing with data cells, not the not the files themselves. Of course, nodes get some files to process, but the engine itself is dealing with cells. This is purely theoretical thing. Let's say you don't need to, you cannot influence how the engine divides files into cells. But it's good to know because of the following slides and how the system overall works. This mapping between the files and cells is done by DQP, and then it sends that information to backend nodes. And backend nodes parse the files and feed these cells into the engine. And you might say, but we basically had the same thing with Polybase. Well, there is a crucial difference. Polybase is Java virtual machine. It's inter-process communication, hence it's much slower than it can be, and it comes with its own challenges. You even saw those Hadoop in error messages, so it's quite different technology. In case of serverless, what we did is basically that we embedded the DLLs, meaning parsers for different formats, CSV, JSON, Parquet. We embedded those parsers as DLLs directly into SQL. So as soon as that DLL reads the file, it provides the engine with the data from files in a way that the engine already knows how to work with, like with the tabular rows. And that's why it's so much more performant than a Polybase. It's quite native technology in this case, and the parsers themselves are quite optimized. Once we have these data sets, they are enriched with the user partitions. So if you have your data partitioned, you can tell serverless how data is partitioned, and it can utilize it for efficient querying, for reducing I/O, for providing you with a better performance, but also providing you with a lower cost, right? Because you're charged per data processed. Hash partitions that you see is something planned for the future. It comes from the Polaris. It's not implemented in serverless SQL pool. Serverless SQL pool is an implementation of Polaris. Hence, these hash partitions are not relevant for our presentation today. So on the right-hand side, we have these input data cells on the bottom, and we have a tasks. Tasks is a fragment of a query. And then we have an output of data cells. By association of tasks and cells, we can achieve theoretically endless scalability, right? Because the scalability depends on the number of cells that you have, right? So theoretically, you can scale as much as there are cells. As we say, that this is auto-scale solution. You should not care how many nodes are there. So let's see how it makes sure that everything works smooth for you. Similar to data warehouse architecture, I guess you're familiar with it. There is data movement channel between the nodes. They need to communicate. They need to pass data back and forth when needed for shuffling. And let's say that you have let's say 2 queries running on these 4 nodes. So each node executes one task, one triangle, one task for each query. And if you get additional load, basically you will throttle, your nodes will become bottlenecks. So the auto scale kicks in before this newly submitted query came in, and used additional nodes and moves workload across those 4 nodes. The good thing is that with auto scaling, your queries are not interrupted; they just keep working. So no disconnection, no need to pause your instance to be scaled up or scaled down. It just happens in behind automatically. Another improvement is that the unit of scale is a node. So if you work with data warehouse, you have some predefined sizes, mostly factor by 2, that you can pick from. But your business usually don't scale that way, unfortunately, right? It scales one step at a time. So you don't want to go from, let's say, 4 nodes to 8 right away, because you are wasting your money in case that you pay for resources. In this case, we can scale up for 1 node if that's needed. This completely happens transparent to the user. This is completely transparent to the user. User just should not care, and there is no impact on currently running queries. So it should be quite nice experience. As it runs in a cloud, and as you can process large amounts of data, let's say petabyte of data, we need to employ maybe hundreds of nodes. And it's expected that at some point, at least, one of those nodes might fail for whatever reason, hardware failure, whatever actually happens, but that node is down, it's not responsive. What happens is that once that is detected, can move tasks to other nodes, meaning that those tasks that were running on node that crashed or whatever will be restarted on some other nodes. From user perspective, query will take a bit more time or some more time, but there will be no error or connection dropped or something like that. So are there any questions so far? Because now we are moving to the actual topic of this session. So let's make sure that everything is clear from previous content.
Yeah. Just let me try to make this more clear. This actually means that even a running query will benefit from auto-scaling, because the running query might be stopped for a short while. New nodes will spin up, and then the query can be distributed among more nodes while it's running. Am I right here?
No, actually, if query is running on 4 nodes and system decides to auto-scale, system can decide to auto-scale only when it receives a new query, because that's the moment when you submit a query, service estimates the resources needed based on query complexity and amount of data to be processed, and then says, okay, I need 6 nodes. And because you already have one query running on 4 nodes, system will say, okay, I need 2 more. It will scale up. For the query that was already running, it will keep running on 4 nodes. Because if we try to reschedule it on 6, it means that you will get inconsistent performance, and it means that we need to throw away work for those 2 tasks that we will move to 2 new nodes. So there is no guarantee that it will work faster. It will probably work even slower if we touch it in the middle of execution. So only that new query that was submitted and further ones will be executed on 6 nodes.
Okay, yeah, but that makes a lot of sense. Thanks very much.
Just wanted to ask, this what you just showed with this Polaris engine, is this only working at the serverless, or is this also working the same way for the dedicated SQL pool?
Dedicated SQL pool works the way SQL Data Warehouse did. So you had this, it's similar, but it's not the same technology. It's a dedicated pool, has still this compute node and control node, shuffling service, just like in a SQL Data Warehouse. So it's only serverless.
Got it. Okay, cool.
Thanks. Okay, let's move to performance best practices. So they're just like in any SQL, you can optimize it by reducing I/O. It's just with the similar techniques, mostly the same, which is a good news for anyone who did optimization in a SQL. And on top of that, if you optimize it by reducing I/O, you will also optimize it for cost, because you're charged for data processed. So reducing the I/O, you are reducing the cost. Unlike other SQLs, where whether you reduce I/O or not, your query will run faster, but you paid for resources, for provisioned resources, so you pay for the uptime, not for the data processed. And before we move to the actual things that you can do to speed up your queries, let's go through some steps. These steps are just for the purpose of this presentation. As you already heard on slides before, we still have these very same query optimization steps like parsing, compilation, binding metadata, optimization, query optimizer, and things like that. It's still there. I just want to present phases in this way so we can more easily understand what we can do for performance in serverless. So any query that you submit, and whenever you submit it, no matter how many times, first it will need to list files. So the very first step is to call storage API and say, hey, give me a list of files from this path. This means the more files to be listed, probably your query will be slower. So pay attention to that. We'll also come back to the number of files and things like that. But that in some cases that was detrimental to performance. Unfortunately, storage latency increases, I would say exponentially as you increase number of files in your folders, meaning that your customers are usually happy with the performance when they list a few thousand files or a few 10,000 files, let's say, maybe even more. But as we move to tens of thousands of files or even more, it can get really, really slow, even a few minutes, sometimes even timing out after, I believe, 5 minutes. But timeout is not the often case, but I have to admit that we had customers complaining with the performance of listing those files. There are some improvements that we are working on, but today, just please keep in mind that listing files can take some time. And there is a trick to see whether your listing files takes too long. You can just do simple select top star from a path. No processing, no joins, group by order, nothing, just select top one. And basically you can get a feeling, if it takes 10 seconds, then it probably listed file for 9, let's say. If it finishes in a second or two, you're probably fine with the listing files. It's just quick. So the next phase after listing files is to eliminate partitions. Oh, sorry, my bad. There is one step in between. After we list files, you provide a path, and you can provide wildcards in your path. So there is some path pattern. Once we list files, a whole list of files at that path and below in a deeper levels of your folder, we apply your path pattern to see whether you want to, let's say, take wildcard.parquet or wildcard.csv. Maybe there are two types of files and you want just parquet files. So we need to match the pattern. It's quite quick operation. And only then we move to the second one, which is eliminate partitions. Eliminate partitions means that you have a where clause, which says basically, hey, read just this folder. Let's say read just year 2022. I will show the example, but basically eliminate partitions means that just remove some files from the list and read the others. So after partition elimination, we actually start reading files and processing them. You can't do much, or actually on a read files phase. There is a general rule for read files. If you're using, you need to have multiple files, because one file is read by one single node. Meaning if you have one file of 100 gigs, it will be slow. But if you have 100 files of 1 gig, we can pretty much parallelize the operation, right? Because we can use many nodes to process the data. Then we are processing the data, and finally we are providing a result set. Speaking of result set, I would like to share a tip. If you're using Synapse Studio, please do not do that for performance-sensitive operations, because Synapse Studio is a web UI tool, and obviously there is overhead because we need to get some data from the serverless SQL pool, and that data needs to be converted in something that's not binary, and then we need to convert it probably some JSON. Then we need to apply it in a grid in a web UI. So obviously not an ideal, especially not for decent sized result sets. So if you want the best performance, please use SSMS. It uses native binary connection, and that's it for this part. Also, speaking of result set, you want to eliminate network latency, meaning we had customers basically spinning up serverless SQL pool and saying, hey, I have a bad performance. Okay, why? So we take a look, and then we see that the storage is in a different region. Obviously, if you have serverless in West Europe and your endpoint in US, it will be slower than it can be. Then we had customers that had a Power BI, which is in different region than serverless SQL pool. So then again, cross-region transfer of data is not a good thing to do. Similar thing happened with the Cosmos DB customers. Those things are easy to check and then resolve, but please keep that in mind that you need to allocate all your resources. So let's move to the actual steps. When you're listing files, please keep in mind that service will ask storage to list all files starting from the first wildcard in your path. So no matter what you put behind your first wildcard, service will ask for all the files, for the list of all files beneath the first wildcard, recursively, like a flat list of all the files beneath that wildcard, no matter the level, the depth level. This can take some time, as we explained. So this particular example is maybe not real world scenario, but it illustrates things well. So you can say, let's say that you have tables, different tables within a table spot. So like customers, sales, products, whatever. You can write a query to list all files for all tables, and then use partition elimination to say, hey, give me just customers. But that makes no sense, right? Because you will list many more files. You will list files for products, sales, and everything just to read customers. Instead of doing that, please hard code the value that you know, if possible, here. And I would like to take a quick break here. I have scenario probably assumes very large number of folders, partition, or very large number of files, partitioned by year, month, date, maybe site, sensor, who knows, maybe a few more things, which means that the number of files explodes. So today, you will probably not be happy with just selecting with using stars for year, month, date, and so on. But you can construct the dynamic SQL. So with the dynamic SQL, you can hard code the values, and basically you will have customers, year equals 2022, month equals 6, and that way you will enable service to list much less files from storage than actually it should. As I said, we have significant improvements in this area that we are working on. But today, if you have a large number of files, please be aware that by reducing number of paths or maybe compacting some files into a less number of files, you can get a better performance. So we quickly move to SSMS just to show the power of partition elimination. So I have a query which reads taxi, New York City taxi dataset. It reads everything. It's partitioned by year. This folder here, where wildcard is year. So this just reads it as this view just reads all rows from these files and exposes or surfaces year as additional column. So this file path function can be used to reference a wildcard. File path of 1 means first wildcard in the path. So basically, when the engine reads these files, it will populate all the columns because you select star, but it will also add additional column where it will populate the value of a wildcard. So this way, your customers can import this into Power BI and filter by year. So one important note, open row set is a function, and it's extended from the function you know in a SQL Server. It's quite enhanced and optimized. And no tool knows how to use open row set, right? Not even from Microsoft. You cannot have query editor. I believe that no query editor can handle open row set function. So in order to surface your data to any external tool for your users, to Power BI or anything, you need to wrap open row sets in a view and expose these views to a Power BI tool. Or maybe you can create external table, but let's stick with views for now. So this view reads all rows from taxi dataset, and the other one is basically the same dataset, but it's not partitioned by year. So in this case, I can instruct service to read just one particular folder, while in this one, service needs to read all rows just to filter out something by date. And let's see the difference. So this first query uses dataset which is partitioned and filters by year, meaning that the service will actually read only those 2 years, only those 2 folders. It will list all years, all files, but it will eliminate all but 2012 and 2013. Obviously, my environment got cold, so this is not the experience I expected. So I'll just rerun it quickly while we are waiting. Okay, so important things to note. This query scanned 575 megabytes, and it took somewhere around 3 seconds. The other one targets a complete data set, which is not partitioned. It needs to open each row, each file, each row group of Parquet file, each row to check the date of this column, and only then decide whether it will skip it or not. This query, the other one, will read much more data, and it will for sure take longer. And it's expected, right? Since it needs to read all Parquet files, it will take more. While we are waiting, I would like just to mention row group elimination. So Parquet files are organized in row groups, meaning that
maybe quick comment on that.
Yep.
Could you please explain this to the IoT Hub team? Because if you write from an IoT Hub to a storage account, it's not partitioned by device, but the queries you usually run are partitioned by device. So the IoT Hub storage account connection is the dumbest you can do when you want to query with serverless pools.
Well, yeah, did I cut off someone?
They don't do this the right way, in my opinion. So maybe you should explain to them why this is a bad way to partition.
Okay, that's a good feedback. Yeah, I would like to understand a bit more about this. Can you explain what's the way that you have it now with the IoT Hub?
If you write the telemetry messages from the IoT Hub directly to the storage account,
okay,
they are not partitioned by device, but your usual query will be partitioned selecting some devices where device ID equals something. So there's no way of eliminating any files if you use the native IoT Hub storage account partitioning to read that from SQL Serverless.
And what format is used for storage?
It doesn't matter at the moment. Usually the default is JSON, but the JSON files contain data from all devices. But usually all queries you run is get data from one device or from a set of devices.
I see. Well, I was hoping to hear that it's per K, but yeah, I see. And thank you for feedback. So in case that there are per K files are organized in row groups, and each row group contains, of course, a set of rows. And each row group has metadata, meaning minimum and maximum values of each column within the row group. So with per K file, we read the row group metadata and compare it with your where clause and decide whether we need to read row group or not at all. So we can skip it. It's not only about partition elimination, it's also about row group elimination that can be done on a per K. With CSV, you cannot do it, and with the JSON, you cannot do that because you need to read the whole content to get the proper JSON, and you need to read the whole CSV in order to parse it, find columns, comma separators, or whatever field separator, and only then you can actually apply the where clause, meaning that you need to read the whole file. That's why per K is so much better fit for serverless SQL pool.
I guess that's the same for Delta, right?
Yeah, Delta is based on per K,
Yeah.
so it's basically the same. Yeah. And I don't recall correctly, but I think it was somewhere around 600 megabytes in a partition data set because we skipped everything. In this case, we scanned much more data, so some 17 or so gigabytes. Just because we didn't use partition elimination and we had to open each file, open each row group, and probably read a lot of those row groups to just find the appropriate rows that we're interested in. So the next thing is partition elimination that we just explained through example. So use file path for that. Important note is that external tables today do not support partitioning. So if you have partition data set, you probably want to use open row set with views rather than using external tables because external tables do not support partition elimination today. Obviously, you want to reduce the amount of data for processing, which means simplify your queries if possible. But probably the biggest impact you can make if you reduce the I/O while reading data from storage. And that's why we said CSV and JSON, we need to read the whole content of files, parse it. So you would do better with per K if you can convert your data to per K, because per K is columnar and is compressed. So the engine can only read columns that you referenced in your query instead of reading all columns from the file. And data is compressed, it's highly compressed. And finally, it's within row groups, so we can eliminate some row groups. Obviously, per K is superior for analytic workloads. So far, I mentioned a few times that with serverless SQL pool, you can only select your data and query it. But that's not quite true. You can use CTAS, which is run this select statement, run some select statement, and materialize the result set into a new set of files in storage and create external table pointing to it. Similar to CTAS or CTAS in data warehouse, it's just that the data is stored in external location in the storage. And this is a common optimization technique, just like in a SQL. When you have a complex, really complex query with many joins, you sometimes end up splitting those queries into multiple queries. And let's say that you have 15 joins, maybe you will do 10 joins and then save the result to the temp table. And then in the next query, you will join temp table with the other 5 tables. It's similar here. You use CTAS to store most often used data or most often joined data or pre-aggregate your data and store the results into new external table in storage. Then your users will target that table, which already has pre-aggregated or prepared data, instead of each user running a query from a report, and each query had to read much more data, process it, and take longer, and so on. Okay, so this one.
Yeah, sorry, there's a question here in the chat, and it's questioning if this also has a cost perspective. What are the costs in Azure? If you're reading with serverless from a data lake, do you also pay for the read operation on the lake, or do you just pay for serverless?
Yeah, good question. So for serverless, you pay for data processed. We can go into details if you want later. But for you definitely pay for storage the way it's explained in the storage pricing, meaning you pay for data at rest, and you also pay for operations. So basically, we need to service a serverless SQL pool invokes storage API to read, release data, read data. So basically, you are charged for those as well.
Okay. Yeah, thanks so much.
Thank you. Just like in Azure SQL, you want to read only relevant columns, avoid star. In case of Parquet, this is even more important because in Parquet, we can read just some columns. Please note, I had multiple questions for some specific cases where customers complained that Parquet and CSV have the very same performance. It's not expected, but there is an edge case. Depending on file sizes, the amount of data that you have, they may have more or less the same performance for select star queries. Why? Because if you do a select star on a Parquet, you will, without any where clause, without any additional processing, basically we still need to read all columns, all rows, decompress it, and basically do the same just like with the CSV, right? We need to read the whole CSV and process it. So if you use star, it will also affect the performance. It's not just about the best practice, it's also about the performance implications. Again, just like in any other SQL, use the smallest data size that will accommodate the largest possible value.
Sorry, one quick question regarding this what you just explained, because like let's say for example, like you have a view that selects ID and name, and that is, for example, like based on a view which does a select star. So would that be bad in the sense, like would it do a predicate push down in that sense that it's just taking ID and name, or would this also be a bad thing that it's first reading everything and then only in the SQL engine does the elimination?
If where clause is not on a partitioning column, then the next step of elimination is a row group elimination. So if it's Parquet, before the engine gets the rows, so that DLL that I mentioned, which parses Parquet file, will apply this row group elimination on a row group level, and even skip some row groups, and then feed the engine only with the rows that are coming from the row groups that satisfy this where condition.
But I mean, like, it's not about the rows, I mean, about the columns, because like in the example that you're just showing, like you have one select star from the storage and you have one select ID, comma name from the storage. And let's imagine like that we are doing select ID name from another, from the upper view that you are just showing, which would mean like select ID name from a view, which instead does select star from the storage. And I'm just asking, like, is it a good idea to do something like this? Because the engine will know that just ID and name needs to be retrieved from the storage. Or is it a bad idea because it will first read select star from the storage and then only knows, oh, I see. Column for that, I throw away the other stuff.
I see. I expect to the query optimizer to be smart enough to eliminate the others.
Okay.
I'm pretty confident in that, but yes, I can double check and get back to you offline.
Okay.
Yeah, so back to data types. For majority of cases, this might be kind of over optimization in terms of, you know, big int, small int, and so on. But in case of character columns, this might make a difference. So if you Okay, so basically this is a thing of a past that, speaking of character columns, this is a thing of a past that I still want to explain for anyone who potentially experienced a performance improvement or different behavior from what it was before. So previous state before a month or so ago was that you really had to take care of how big your character columns are. It will work with varchar max. Even schema inference, the service will assume that if column is of character type and you don't specify the type, it will assume it's large one, varchar 8000, but it hinders performance. And we had a lot of customers complaining, hey, I need to specify the length of character column. Why? Well, basically the left-hand side will perform slower than the right-hand side. If your value is small, keep your length small. That was the rule, basically the first best practice that we checked whenever we are debugging or troubleshooting performance problems. The reason is simple. As you know, Query Optimizer relies on statistics to produce optimal plans, and also relies on data types and to decide on resource estimations. The caveat is that in SQL Server, there are no statistics for lobs. So for max, if you write it, there are no statistics. So we know basically nothing about that. We assume, engine assumes it's a quite large one, and then it produces a suboptimal plan and provides wrong resource estimations. I mean, a lot of places things can go wrong. If you use varchar 8000, things are better. You may have statistics because it's supported. It's not a lob. But still the resource estimations will be quite bad because the engine would assume that it's long 8,000 characters instead of maybe 10, 100, 200 characters. So that was the state up until a month ago. So you probably saw in this Synapse blog, monthly Synapse blog, if you read it, that like a month ago we had this improvement of average column length and cardinality estimation. So now if you have a character column in your query, either defined by you explicitly with the with clause, or that the service did with the schema inference decided it's a character column, it will calculate the average column length by sampling the data, similar like statistics, right? It will just sample the data and it calculate average column length. And you get much better performance because you have much better resource estimation and you can create a better execution plan, right? So this is the only part of the presentation that shows the how it was. Now it's much better. And now you should really not care since a month ago about the length of the character columns.
One quick question regarding this. Will this also show up in the metadata, or will the metadata still show up varchar 8000 in the Synapse Serverless?
This feature cannot change the metadata because it would break a lot of customers probably. So the metadata is as it is. It's just that internally system is aware of average column length, just like statistics. You don't see it. It's there.
Okay.
The engine uses it, but you don't know about it. It's same here.
Okay, good to know.
Okay, so, and that's a very good question. Thank you. I forgot to mention that. It's quite important. So metadata stays the same. Average column length is calculated, and there is another consequence of this improvement. When you first come to your endpoint, there is no statistics, right? When you first start querying some data, there is no statistics for the data set. Some queries are quite simple, but require statistics. So with average column length, we can calculate better cardinality estimation because you estimate the number of rows and then divide it by the average column length. If you have a better average column length, which you have now, you have a good one, then it means the cardinality estimation will be better, ultimately resulting in better resource estimations and even better resource estimations and better plan. Okay, this one is always good to check. Inferred data types may or may not be correct. As I said, inferred data type from Parquet it's easy. Parquet has metadata which says this is the data type, exact data type, date or integer, whatever, and that's it. The engine just treats it. For CSV, schema inference will assume data types based on the first 8 megs, I believe, from file, which means that it might not be correct, right? Maybe first 8 megs have in the first column all integers, but sometime later you have a string. So when you run a query, it will fail because it assumed the wrong type. So it's a good idea to check in for data types just to make sure that it's correct. And you can use this store procedure describe first result set, which is already existing in SQL Server. It also works for serverless. You can find how you can use it in a best practices article in a serverless SQL pool. Okay, so now these were the crucial parts to understand. Now we're going into, I would say, a bit advanced or more details. File path function that you use to expose or work with the partitioning columns have a return value of type nvarchar 1024. Why? Because storage path is of that type actually. So if you want optimal performance, it is a good idea to cast file path to whatever you need it to be, especially if you're surfacing it, right? Because if it is a year, it makes no sense to expose a year like nvarchar 1024. You will help even a Power BI if you say, hey, cast file path as a year, so the Power BI will understand it's integer. Then use nvarchar type if the underlying text is UTF-16 encoded. Well, this is more of to avoid wrong result than the performance improvement, but it's good to know. Also use varchar type with UTF-8 collation if the underlying text is UTF-8 encoded. Well, that all makes sense, and it especially makes sense, for example, in Parquet, because Parquet itself has no notion of collation. And all the engines, libraries that write Parquet files are using this UTF-8 encoding and binary sorting. So there is no notion like, Latin letters, Cyrillic letters, or maybe Japanese, Chinese, or something like that. It's just a binary stream. That's it for Parquet. But when you're working with a SQL, you have a notion of collation. So use this one, use UTF-8 collation to get to avoid wrong results. So you have always the proper reading of your data. And now I'm coming to performance tip. Use Latin general 100 bin to UTF-8 collation on string columns or any other partitioning or any other column where you use filters. And this is especially important for row group elimination. And now I will explain why. Obviously, UTF-8 is important because UTF-8 is used as encoding in Parquet. Bin2 meaning it's binary sorted. So basically, that's the native way that Parquet data is stored. When we apply row group elimination in SQL semantics, depending on a collation, you can get different results if you try to say larger than some character value or smaller, because collation decides on ordering. So the only way to use row group elimination today in serverless is to use this collation for your string columns from Parquet. And you can alter the database level collation and then write your queries, or you can specify data types and collation within the open row set, if you like, whatever suits you. But it's important that your columns in the table need to be of this collation in order for row group elimination to kick in, for character columns, of course. So I would like to show the effects of row group elimination. So here I have a file that is highly optimized, let's say, for this session. I know that this file here has multiple row groups, but it does not have mixed values across the row groups for this column PU location ID. It means that if I say PU location free, I know because I created a file for purpose of this session. If I want to read PU location ID free, I know that such rows are only within the two row groups, and there are more row groups in the file. Similarly, I know that the PU location ID 2 is located in only one row group, and I want to show the effects of the row group elimination here. So this one reads two row groups. Let's not focus on a seconds, at least not for this case. We also want to see data processed. So this one had to read 140 megs. So two row groups, this size, read every row within those row groups just to find rows with a PU location ID 3. On the other hand, I will now run a query that will target just one row group, which scanned 47 megabytes. Of course, when query scans less data, it's faster and it costs you less. And why I'm emphasizing this, you see how much difference it can create for integer columns. So now imagine how much difference can you make by using proper collation. So if you have a where clause on a character column, your queries will run way faster. And now we are coming to some general guidelines. We already touched some of them, but worth repeating. So you want to collocate your storage with serverless SQL pool, and you want to collocate your serverless SQL pool with the client, being IIS or Power BI or whatever tool you use. The same applies to Cosmos DB, analytical storage. You need to prepare files for querying. Well, this is a tricky topic, right? There is no scientific approach or I would say formula that I would be able to share to tell you need exactly this number of files of these sizes, but I can provide some general guidelines. You definitely don't want to have one file because one file can be processed by one node only today. So if you want to have a faster processing, just divide files into multiple. And let's say some rule of thumb, at least 15, 20 files to be there at least for a table. Again, it doesn't make sense to split 10 megabytes into 20 files, right? But if you have few gigs of few hundred megabytes of CSV files, yeah, definitely you need to split it. If you have 20 or plus megabytes of Parquet files, it's worth splitting. On the other hand, please don't oversplit your files, because if you have tens of thousands of them, you remember listing all those files will take time. So you need to find some reasonable balance. The engine will always try to, speaking of sizes, file sizes, engine will always try to distribute your files across nodes in a way that each node processes more or less the same amount of data. And it's easy thing to do if you have many files, right? The more files you have, probably the engine have more options to distribute files more evenly. But anyway, having balanced file sizes always helps, right? If every file of yours is, let's say, 10 GBs, and just a few 9 and 11 GBs, the engine will quite easily distribute those files for equally sized processing on nodes. Partition data by storing different partitions in different folders. Well, we mentioned that. You can use this file path function not only to filter by folders, but also by path names, because from the serverless engine perspective, path and the wildcard is just an array of strings. The engine doesn't care whether you put a wildcard on a folder level or on a file level, or maybe you maybe don't have folders at all. You can name your files file 2022-06 and so on. And basically you can put a wildcard at the place of 06 and then just target that part of Python. So we call it partition elimination, but probably the proper way to call it is both folder and file elimination. Serverless SQL pool reads files from storage, so obviously its performance depends on storage latency. So make sure that your storage is not stressed with other workloads. You can check Azure storage metrics. To be honest, I had just a few customers that actually had this case when storage was stressed, but it's always good to follow storage metrics, because it's not just about how storage stress is. Maybe you're not using it, but sometimes latency is not as great as it should be. So you can see that there as well. It's not happening often, and we have mechanisms implemented some time ago to smooth this spikiness in the storage latency, similar the way Spark does it. So basically, we fire call to storage to read some file, and if it doesn't reply within some short time frame, we just discard that call and fire another one. It's quite simple mechanism, but it works. So you should not see this anymore. But anyway, if you have issues, good idea at some point, if you exhausted all best practices for serverless, it's good to check the Azure storage metrics. If you have to use CSV files, we have 2 parser versions. You can find it in open roasted documentation. Version 1.0 is pretty much what you got used to in a SQL Server. So it's fully feature packed. You can read different data formats and a lot of different things, but it's much slower. It's single threaded. We improved it with those arguments in open roasted, but so you can provide different arguments. You don't need to create a separate file as a format for open roasted function as you have in a SQL Server. Now it's quite easy to use it, but parser version 1.0 is not as performant. Parser version 2.0 is significantly faster because it will span multiple threads to read the same file at the same time in parallel. So it's much faster, but it comes with a caveat. Not all features are supported. For example, lobs are not supported. Row size is 8 megs. It cannot be larger today. And probably one of more important differences is that it does not support all formats for date time. So just a few, like year, month, date, and hour, minute, seconds. So you can overcome that by reading it as a character and then casting it in a select statement. It's not quite elegant, but it's workaround that works today until we improve it. But I believe that performance improvement is good justification to do so if you have to, as I explained, with the dates. If you don't have different formats of a date, then you're just fine using 2.0. As we mentioned, the query optimizer heavily depends on statistics to create optimal plan, which means that either you have to create statistics manually or service needs to create statistics automatically when statistics are needed for the first time. So we have auto statistics for Parquet. We don't have it today. We are working on it, but we don't have it today for CSV files. So when you're querying Parquet files, you just don't care. You just query it and that's it. If you're querying CSV files, and then it's a good idea to create statistics manually for distinct columns, group by, order by, join, and the where clause. So basically those columns Query Optimizer needs statistics for. So if you create statistics manually on top of CSV files, your queries will perform significantly faster. And it's fair to say what the limitations are in terms of performance mostly. Well, we mentioned single file is processed with a single node. It's a current limitation. Tens of thousands of files. If you're targeting tens of thousands of files with your path, then slow file listing may kick in. Maximum result set size is 400 GB. Why is this important? I mentioned that Power BI import mode is kind of hero scenario for serverless SQL pool. You can use it for other scenarios as well, but Power BI import or AAS import mode, it's quite a good fit for. So those tools fire queries in parallel, meaning that your result set size, aggregated result set size of all queries can become large, right? Big. And if you remember from the first part of presentation, in serverless SQL pool, the whole result set lands on the front end before the engine streams the first row and all the others to the client. So obviously, if you run, let's say, 10 queries, each query returning 41 GBs of data, at least one of them will fail, right? Because there is a limit. We had customers hitting it when we had somewhere around 100 GBs, then we increased to 200 GBs. Then we had very few customers complaining about that. Now, since we increased to 400 GB, we don't have such complaint, but as you know, there are so many customers, so many use cases, someone can hit it sooner or later. What we do in that case, basically we propose to reduce the level of parallelism or to parallelize, to import tables per partitions. So basically you're importing partition at a moment. And that way you can import multiple partitions at the same time, but with the ultimate goal to reduce total result set size of the queries running at the same time. There is a 30-minute timeout for distributed query execution. So you submit a query, it hopefully starts running immediately. If not, it probably waits for resources, which might happen. So once it gets into the scheduling phase, which includes waiting for resources, the timer starts ticking. So you have 30 minutes for a query to finish in distributed query execution. We had customers reporting performance issues when queries are running longer than 30 minutes. So it is not expected to see a query running for more than 30 minutes. Either one of two things happen. One, something is really wrong. And I would say often, or even every time, it was due to usage of Synapse Studio, because the result set was really, really huge and Synapse Studio could not handle it for whatever reason. It got stuck, and basically, for the customer perspective, it looked like it executed for an hour or more. but anything more than 30 minutes. The other case when it can run for more than 30 minutes is if your distributed query execution finishes within 30 minutes, but then the result set starts streaming to the client, then the timer is stopped. So theoretically, you could run your query for a minute. It can be executed in a minute, and then your client can be slow or stuck, whatever, and streaming result set can take more than 30 minutes, more than 1 hour, whatever the duration is. Today we don't have a limit there, but sure we will implement some limit for this streaming sooner or later, just to prevent the misuse of the service. We mentioned parser version 2.0 does not support lobs, and there is no auto statistics for CSV files, so you have to create those manually. So yeah, that would be all from me. So now let's move to Q&A. Are there any questions? I don't see a chat.
Let me check the chat. In the chat, there are questions.
Now, the first question would be if the system is actually based on a service fabric cluster, or what kind of technology is running underneath?
Well, it is a service fabric. Yeah, well, actually, I would need to get back to you offline on this one. Okay. Whether it's a service fabric or not. Basically, what the information I can provide is that there is a set of prepared, cleaned up pools that are waiting to be associated to your endpoint. So when you connect to your front end, if you didn't use it for some time, we may take it away from you. When you connect to it, your first connection will fail. You probably know about that if you use serverless SQL pool. But there is a set of front ends that have no customer context, no subscription context, but they are prepared in terms that some SQL server is there and ready to be associated with your endpoint. When it gets associated, basically we apply certificates, which are automatically generated. So basically no customer has the same certificate. And then it's ready for you. The same applies to backends. This is a different set of, it's in a set of prepared backend nodes that just wait to be associated with your or any other customer endpoint. Exact technology behind it, yeah, I would appreciate if you can write a query in a chat or send by email, and I can follow up.
The next question, I think you already answered before. The question is, when reading from data lake, do you have to pay for the read operations on the lake? I think you already said that this is the case.
Yeah, it is. Yeah. You'll pay for storage data at rest and for storage operations, reads. Or writes if you are using CETAS to materialize the result set. Sorry, I cut you off.
Another question?
Another question. Is there a difference between Delta format and Parquet format, or is already this much the same from the performance perspective?
That's a very good question. Speaking of anything related to Parquet files, it's exactly the same. So I'll focus on differences. In Delta, service reads those manifest file and checkpoint files and parse those JSONs to understand which particular files should be read. If you're querying Parquet files, then we have this listing phase. Basically, there is no JSON in regular Parquet files tables. There is no JSON that will tell you read only these 2 files out of 10, let's say. But we need to list files. No matter how many files are there, we need to list all files and then decide what we will actually read all of them. So it's difficult to say one is faster than the other. What I can say is that Delta should be pretty much the same, assuming that you don't have many checkpoints. So that's one of best practices for Delta is to compact your files and vacuum files, meaning remove orphan files. But compacting helps more than vacuuming, right? Because we don't care about old vacuumed orphan files. We care only about JSON files, so less JSON files, less processing on our side to understand what files should be read. And their things are interesting. So if these are reasonably small, JSON files, and there are not many of them, then it's pretty much the same. If there are many checkpoints, Delta can get really slow when querying from serverless. But good to know is that we are heavily investing into it. So we are optimizing day by day. Some improvements landed, some improvements will land. So yeah, Delta is also preferred format.
Okay, thanks.
Okay. And then we have another question from the chat that if data processed also is more than only data read from storage, but also the results that's in the internal shuffle data. Is that?
It is. I will briefly explain what it is, and I will share article for quite detailed explanation. So unfortunately, it's called cost management. So if you find cost management article for serverless SQL pool, you will find data processed and how you are charged in quite detail. So I will just quickly go to this, and if you need more details, ask or check the article. So data processed consists of data read from storage, which includes data and metadata. Let's keep in mind that we want to optimize I/O, so we also do prefetching. So maybe we need just 8 megs of your file, but we will read like 64 or something. Those are insignificant changes, but if you want to go into details, that's important as well. Then if you're reading Parquet file, we are not reading Parquet file entirely and then reading segments as we need. We need to open Parquet file, we need to read the first Parquet magic numbers, like those 4 bytes. Then we move to the end of the file to also read Parquet magic numbers at the end, length of metadata. It's just how Parquet works. Then we traverse back to the beginning to read a metadata of file, and only then we start reading data. So there are some API calls and reads for metadata. It's insignificant increase, but it's still there. So reading data and metadata is probably the largest factor in at least initially, especially data. Then there is intermediate results. If nodes shuffle, and an important point, data scanned is in the compressed format if it's Parquet. But once data gets into the system, it's in a SQL format. So if data is shuffled between the nodes, that amount of data is also counted for charging, and that's in uncompressed format. So if you have 10 GB Parquet, which decompressed is 100 GB, you will be charged 10 GB for reading and 100 GB if 100 GB is shuffled. Let's say that you just did select star from Parquet, everything decompressed, everything streamed to you, so it's 100 GB. So it's extreme sample. So it's not only shuffling between the nodes, it's also shuffling in terms of sending results to the front end. So if your result set is additional 10 GBs, you will be charged additional 10 GBs. Then there are statistics. If auto statistics kick in, it's just another query which reads sample of your data. So you will be charged the same way for it. And basically, that's pretty much everything that's there. You're not charged for metadata reads, like select Zvezda from sysview, select star from sysviews, sorry, select from metadata catalogs and things like that. Okay. So if you want additional samples and more details, yeah, just either ask or check this link that I shared.
And then there's 2 more questions now. First is when querying Delta Lake with serverless pool, are only the Parquet files read, or is the metadata files, are they also used in any way?
If metadata files mean those JSONs, Delta manifest and the checkpoints, then yes, those are it.
Okay.
But they are usually insignificant in terms of size comparing to the actual data. I see a question from Harris: how to make sure a view built on Delta Lake eliminates partition while querying? Okay. Well, few things there. So basically, first, your Delta needs to be partitioned, obviously, and you can check it by selecting from the table. By default, it will be utilized. There is no reason not to for it to not to be utilized, but you can select the data set with a where clause and without a where clause, and basically you will see a different data scanned. Or maybe you should not scan the whole data set. You can scan a few partitions versus one partition, and then you will see the difference.
Okay. I have one more question. Just to make sure I understood correctly. So regarding statistics with the newly brought features to the service, does that mean you're not anymore forced to create statistics on your own because they're already always created automatically? Or is it still valid to create statistics like after an ETL load?
Just like in any other SQL, it's good to recreate statistics if distribution of columns changed. So yes, periodically, if not every day, yeah, periodically you should recreate statistics. Okay. So automatic statistics, just for clarification, automatic statistic creation exists for Parquet files, but it does not exist for CSV files today. We are working on it. So for CSVs, you have to do it manually anyway for creation. For updates, at this moment, external tables do not support auto statistics update. Also another thing that we are working on, while Open Row Set supports auto update. So please keep that in mind.
Mm-hmm. Okay, then you can see the chat yourself now. So let's maybe move on to the question about the database projects.
We will need to check about it. I think it's not something that we work at the moment, but yeah, I will need to check on that.
Okay. And then the optimization question. Does serverless optimize during query sessions based on averages from previous queries?
Yeah. So today not. In the future it might.
Okay. Okay. Last thing which I would be really curious about, like you talked all the time about using views in conjunction with Open Row Set. Like, is it basically like a valid point to use external tables instead? Like, is there any difference, or why are you always referring to view with Open Row Set?
Well, another good question. So I refer to view plus Open Row Sets as that's the easiest way to write a query. This is kind of a bit of history. In a polybase, you just have to create external table, meaning that you have to create external data source, probably credential, file format, external file format, and only then create external table, and only then you can query it, right? So Open Row Set, it's just way easier to start. That's the first reason why I spend more time there than external tables. Because once you build your solution, try out serverless, check your data files, whatever, then you can move on to productizing your logical data warehouse or ETL pipeline, and then you can decide whether you want to use Open Row Set or external table in I would say production pipeline. There is performance difference too, actually. One is quite significant, and that the external tables do not support partition elimination. You can use external tables to read partitioned tables, but basically you cannot access partitioning column because it does not support partitioning, and it cannot read the column value from the folder name. That's something which is, of course, something that we want to address. So if you have partition data set and you need partition elimination, yes, you have to use Open Row Sets. The other difference, which I would say is insignificant comparing to the previous one, is that automatic statistics update is supported for Open Row Set today and not for external table. So yeah, sure, as the service is being improved, that will come on the plate, but not today. Of course, there are things where external tables are maybe more favorable, and I would say this is more natural way, the way everyone used to work with other SQL. So in terms of setting up security, it is probably easier to work with external tables. For Open Row Set, you need for a user to be able to use Open Row Set, you need this administer bulk operations. While for external table, you only need to grant select access to an external table, and basically that's it. So there are security differences, but performance-wise, Open Row Set is still a way to go. I see someone writing the question. Yeah, Benjamin, did I answer the question completely?
Yeah.
Sorry. Yeah.
Totally answered. Thanks.
Great. Thanks. I see Stefan is writing.
Yeah, maybe we can take another last question.
Because we have to move
past writing.
Yeah, we have to move out of the location here. So we take one question, Stefan, and then that should be it. Okay, here you go.
Stefan, yeah, if we have time for this question, Stefan, can you please clarify the question?
Yeah, Stefan, feel free to unmute yourself and ask for yourself.
Yeah, need to find the right place on the mobile. When I compare the serverless SQL with links and open row sets and external tables with Polybase, there's still lagging behind the options for external data sources to be connected. Is there any progress on that on the roadmap? Linking other relational databases? Oracles?
At this moment, not, but yes, that's something that we are considering, and we'll probably also consider for the following planning sessions, semesters.
Mm-hmm.
Cool. Filip, thank you very much.
Welcome.
Yeah, it's
Thank
been
you.
a great session. I think everybody learned a lot.
Absolutely.
Yeah.
So thanks.
Well,
we really appreciate it.
Mhm.
And hopefully next time you'll be able to travel to Germany and we'll have a session in person from you.
Thank you very much. Thank you all for joining. I enjoyed this discussion, and I also hope that I will meet you in person soon.